Good day, welcome back to Physics with Mr. Adams. Alright, so now what we're going to do today is that we're going to look at some multiple choice questions. And as we know that multiple choice is not one of the easiest exams to pass because, having four likable answers for any given question makes it a bit more challenging to get the correct answer. You either get it right or you get it wrong. And one of the things that you should know about a multiple choice exam is that it encompasses the whole syllabus, right? So it means that you need to have an idea of what you are doing, or you need to have a thorough knowledge of the entire syllabus in order to do a multiple choice exam. It's not just a one hit and you score, or that you try and A, B, C, D, E, or whatever, any, mini, miny, mo. So what we're going to do today, we're going to try to look at some simple questions to see how we go through to answer them. All right. All right. So number one question. Normally, one of the easiest questions that you may find on the syllabus. They always ask you about the basics of the fundamental quantity or the derived quantity. Says that a physical quantity which is not one of the fundamental quantities is, as we have A mass, B time, C current, and D density. So when it says fundamental, it basically asking for basic quantity, and therefore which is not a basic quantity, and as you should know, that answer should be D. All right, D should be your answer in this case. Number two, we have a number here, 0.0000357 newtons expressed in standard form. And as you know, standard form is where you want the decimal point to move so that the number now falls within the range of 1 and 10, so 9.99, right? And the power basically should be the number of places you move the decimal place so that the number falls within that range. And if you move the decimal place to the right, then the power should be positive. And if you move the decimal place to the left, the power should be negative. So in this case, the most appropriate answer there is A. All right. Next one. How many significant figures are in the quantity 25.92? Now, as it says, significant figures looks at the non-zero digits, the first non-zero digits, right? Starting from the left. Now, in this case, the number is 25.92, right? And the first non-zero digit from the left is the 2, then we have 5, then 0.92. So it begins, so your most appropriate answer there, the first non-zero digit, and how many digits you have there, the answer there will therefore will be D, right? D. All right, so we have a next question. Which of the following instruments is suitable for measuring the diameter of human hair? All right, so measuring the diameter of a human hair. And we have four possible answers here. We have tape measure, vernier caliper, meter rule, and micrometer screw gauge. Right? Just ignore the fact that it says 4, 5, 6, 7. It should be A, B, C, D. Alright? Now, each of these instruments measure the quantity length. Alright? But we want to see which of them measures the minute quantity, which is the diameter of a human hair, which is very small. And so we want a instrument that is going to be measuring in millimeters, the smallest unit possible, right? So that eliminates tape measure, that eliminates vernier caliper, which measures in centimeters, and eliminates meter rule. So the best possible answer there is the micrometer screw gauge, which gives you the unit in millimeters. Good. So D should be your answer there. Right. Number 5, 1 gram is equal to. So we want to see what is 1 gram equivalent to, and we have all the answers there are in milligrams. So we want to know how do you convert from grams to milligrams, and that is where you divide by 1000, right? So Right. 1000 milligrams, right? So to go from a larger unit, which is gram, to milligram, which is a smaller unit, you multiply, you multiply by 1000. So it becomes 1000 milligrams. Good. Number 6. When used in front of a unit, the prefix mega means what? Right. So mega means multiply by 10 to the 6th power. Good. Multiply by 10 to the 6th. And that's positive 6. Right. Number 7. A sliced bread is squeezed into a little ball. Which quantity does not change? Which quantity doesn't change? Right. So when we talk about a sliced bread, if we change the shape of it, we actually change in the dimensions, right? And in terms of compressing it down to into a smaller shape. So in this case, we have mass, volume, density, weight. Which quantity doesn't change? So one, when we change the shape, the width is going to change. Also, we're going to have a change in the volume because it's being compressed, right? So the volume is also going to change. Now, because the volume changes, it's going to trigger a change in the density. Good. So therefore, the plausible answer there is the mass, right? Because the mass of a quantity of any object doesn't change once it stays, nothing is broken off of it. It's still the same amount of mass. Okay. Number 8. I'm going to look at the pendulum now. It says the period of a simple pendulum is most affected by, and that answer there is the length of the spring, right? The length of the spring. Good. So that is one of the major factors that influences the period of a pendulum. Number 9. So we have an object there, and we want to be able to read the reading. So it says item 9 refers to the following diagram, which shows the section of a thermometer. And if you notice there that the graduations there are going up in twos. It goes from 80, then to 90 here, and five graduations in between. So that therefore it shows 82, 84, 86, 88, then 90. Good. So therefore, the best possible answer there is 88, right? 88. Next question. All right, so this one says, which of the following is not a vector quantity, right? Now, what you know that you have two different types of quantities. You have what is referred to as a scalar quantity, where is a quantity that has magnitude only, and then you have a vector quantity, which is a quantity that has magnitude and direction, meaning it has a number value and it goes in a specific direction. Good. So we're saying which of the following is not a vector quantity, and in this case we know A, displacement, is a vector quantity. C, acceleration, is also a vector quantity because it tells you how fast you're going in a given the rate at which you go in the velocity in a given direction. Momentum is also a vector quantity, and in this case density, which just tells you the mass per unit volume. It doesn't have to be in a specific direction, so therefore B is that answer. It is not a vector quantity. Number 11, which of the following is suitable for measuring angles? And as you know, all these different instruments: the compass, the protractor, the ruler, the thermometer, and the answer for that one is the protractor. The protractor is the instrument used for measuring angles. Number 12 refers to the following diagram of a dam, right? As we can see there, it's a dam and it is filled with water. Good. Now the question is, The diagram above shows a dam, and the pressure on the dam at the bottom of the reservoir depends on. So we want to find out what is the pressure at the bottom of this dam. So A, it says the depth of the water, B, volume of the water held by the dam, and C, mass of the water held back by the dam, and D, the length of the reservoir. And as you know, when you're dealing with liquid pressure is dependent on, well, three things: the height of the liquid column. Also, we have two, the density of the liquid, right? And what we can have here is A is the most appropriate answer. We talked about the depth of the water. So right, for number 12, A is the most appropriate answer there. Number 13, the mass of an astronaut is 70 kilograms when standing on the moon. Good. When he returns to Earth, his approximate weight will be what? All right. What will be his approximate weight? Now, as you know, mass is constant no matter where you go. Right. The only thing that changes is your weight due to gravity. All right. Now, when he's standing on the moon, his mass is 70 kilograms. When he comes to Earth, his mass is going to be the same value. Right? So now when it says when he returns to Earth, his approximate weight will be what? Now, so what will be his mass? His mass will still be 70 kilograms multiplied by gravity on Earth, which is approximately 10 newtons per kilogram. So, sorry, the answer there should be D, 700 newtons. Right? 700 newtons is the answer. Answer there. So, number 14, a car traveling at 12 meters per second is brought to rest uniformly in 10 seconds. The distance it travels in this time is what? All right. Now, as you know, distance is speed multiplied by time. All right. But not just any speed, it is actually the average speed. Now, it says the car is traveling at 12 meters per second and it is brought to rest uniformly in 10 seconds. So it means over a period of 10 seconds, that speed is actually slowing down. So it is slowing down from 12, then another second the car will be moving at 11 meters per second, another second it might be moving at 8 meters per second, and so forth. So what you want to find over that 10-second time frame is the average speed, right? So the average speed will be the final speed and the initial speed divided by 2, right? So the average speed there will actually be 6 meters per second in a time frame of 10 seconds, giving you a distance of 60 meters is covered, right? So distance is equal to average speed multiplied by time, giving you the answer B, right? Number 15, linear momentum is what? Right, so linear momentum, as you should know, it's the product of the mass and velocity. Number 15B. Alright, number 15B. Number 16. Which of the following features must be present in a stable, well-designed racing car? Right, so in this case, we're talking about stability. Right, stability. And two of the main factors that influences stability is having a low center of gravity, two, having a wider base area, right? And also force also affects stability. So in this case, we want a well-stable design race car. So the most appropriate answer there will be A, having a low center of gravity, right? Number 17, when a ball is thrown vertically upwards and reaches its maximum height, it has, and then we have options, maximum kinetic energy and maximum potential energy, and so forth. Alright, so this question is just like what you will see in cartoons. Now, you know, in cartoon, a cartoon character is going to run off a cliff or is shot into the air. And as you see them flying high up into the air, then you will realize that they eventually pause, and not until they realize that they're up in the air is when they look down, you see they fall. Now, at that point, when they're up in the air, you realize that they're stationary. And having been stationary at that height means that they have potential energy, a maximum potential energy, and they're not moving. And because they're not moving, it means that they have no kinetic energy. So they have minimum kinetic energy at that point. Good? So that is a concept that happens in real life, but it happens much faster. So in this case, we're going to say that it has maximum potential energy and minimum kinetic energy. So the answer for number 17 will be C. All right? C is the answer there for number 17. Number 18. Which of the following are renewable sources of energy? Right, renewable sources of energy, it means that these sources cannot be depleted, that they are not naturally replenished. So in this case, we have solar energy, which is energy from the sun, wind energy, which is energy from the wind, and geothermal energy is energy from hot rocks down on the earth's surface. So in this case, the most appropriate answer that applies is D, which is all of them. They're all referred to as renewable sources of energy. Right, so 18 is D. 19. Which of the following is most likely to account for the fact that pot handles are usually made of wood or plastic? So we have conduction, convection, radiation, evaporation. And what you're going to notice is that conduction, convection, and radiation are actually the processes of heat transfer, right? And conduction is the transfer of heat in solid objects. Convection is the transfer of heat in fluid, meaning in liquids and in gases due to convectional current. Good. And radiation is the transfer of heat in gases, right? Where it doesn't need a medium per se to happen. It actually travels in waves. Evaporation in this case is the change in state from a liquid to a gas, right? And evaporation happens at any temperature. Good. So in this case, you say what is most likely to account for the fact that pot handles are usually made of wood or plastic, and that process is A, right? Conduction. So when you're cooking, you don't want the pot handles to get hot, so therefore you use it with an insulator, right? So wood or plastic material are insulators, meaning that it does not allow heat energy to pass through it. Let's look at number 20. It says that the specific latent heat of vaporization of water is 2.26 by 10 to the 6 joules per kilogram per Kelvin. And when 0.01 kilograms of water is converted into steam, we want to know what happens. Does it absorb or does it give off or give out heat energy? Right? So we're saying that specific latent heat of vaporization is changing state. Right? This is when you're changing state from a liquid to a gas. Good? Now it says that 0.01 kilograms of water is converted into steam. So it means that the liquid would have gained that amount of energy in order for it to change state. Right? In order to change from from a liquid to a gas, it is gaining heat. Good. So in this case, it is absorbing heat energy. Now, what do you notice there? We have two different set of values. We have 2.26 by 10 to the 4th and 2.26 by 10 to the 8th. Right? Now, the answer in this case will be B. Right? Because it is 0.01 kilograms. And if we were to multiply 0.01 by 2.26 by 10 to the 6th power, it actually goes up by 10 to the 8th. Number 21. So the answer there was B, sorry. B. Good. 21. The specific latent heat of vaporization of water is the energy required to change 1 kilogram of water at we have A, B, C, or D. Now, as I mentioned, that specific latent heat of vaporization is changing water to steam, and that change occurs at a constant temperature. When there's a change in state, there is no change in temperature. Whenever there's a change in temperature, there is no change in state. Good? So in this case, changing water to Right, so changing water to steam, and the water only changes state at a fixed temperature, which is known as the upper fixed temperature of 100 degrees Celsius. So the answer in this case is C, right? 100 degrees to steam at 100 degrees, right? So water at 100 degrees is going to change to steam at 100 degrees. Number 22 says the temperature on a warm day in the Caribbean is about, we have 32 kelvins, 240 kelvins, 273 kelvins, and 305 kelvins. Now, in this case, we have to know how to convert our scales. Know what how to convert degree Celsius scale to Kelvin scale, all right, and vice versa. Now, what we know is that the temperature in the Caribbean might be around 30 something degrees Celsius and so forth, right? But what we need to understand is that 0 degrees Celsius is equal to 273 kelvins. So that is going to eliminate a number of your answers there. It is going to eliminate A, B, and C, because we know that 0 degrees Celsius is equal to 273 Kelvin. And right then we can understand that D will be the most appropriate answer, right? In terms of knowing what the temperature of the Caribbean is going to be. Okay, with just by the process of elimination, by knowing how to convert degrees Celsius to Kelvin. All right, so 22 is D. 23, the specific latent heat of fusion of water is 340 kilojoules per Kelvin. This means that when 10 grams of water freezes, right, so we want to know what happens here. So specific latent heat of fusion in this case is changing from a solid state to a liquid state, right, for one unit of mass. Good. Now, in this case, we're looking for 10 kilograms of water. Good. Now, changing fusion of water. Right, so we're looking at water freezing. So it means that this liquid is actually cooling down. It's not going to be gaining any heat. That's the key word that you have to look for in the question. It is going to freeze. Alright, so it is going to freeze and it's going to lose heat energy. Alright, so because it is losing heat energy, we know that it is going to be a heat given out. And in this case, the most appropriate answer is going to be 34 kilojoules. Alright, so as we know, right, so E equals ml. Let me see if I can write that there for you. E is equal to E is equal to ml. So because E is equal to ml, when we rearrange the formula, we're going to see that the mass multiplied by the specific latent heat of fusion, so 10, right? When you cancel out, it gives that answer of 34 kilojoules. Number 24. Right, so we're going to start looking at waves now. Now it says here is that the diagram which shows an instantaneous profile of a wave traveling across a water surface. Now, if we look at the graph, it is a displacement versus position graph. A displacement versus position graph. That is very important that we need to understand the different types of graphs. right? So it gives you displacement going vertical, so it shows you from this point up to that point, that's the amplitude of 2 centimeters, and from this point to that point, that's the amplitude again of 2 centimeters. So going up, it gives you a maximum, which is your crest, and then going from here go down, that's your the trough, right? And the amplitude is the same in the crest and the trough, because this is right. So it's a displacement versus position graph. Now it the question asks you, from the information given, the frequency is. Now, what frequency describes is the number of waves that occur per second. All right? Frequency describes the number of waves that occur per second. And in this case, this graph does not give you any time frame. So because it doesn't give you any time frame, it cannot give you the frequency or the period. Right? It cannot give you the frequency nor the period. So therefore, the answer for this question is going to be D. It's going to be D. All right? It's unknown. There's no way you can determine the frequency here. Number 25. Right, so it says, refers to the following diagram, which shows Pam facing a plane mirror, which is 8 meters away from her. So when we look at Pam, Pam is standing here, and the mirror is 8 meters away from her. Right? It's 8 meters away from her. Now the vase is 0.5 meters from Pam. But if she looks into the mirror at this distance of the vase from the mirror, is the balance here, which is 7.5, and then it is another 7.5 behind the mirror, plus the 0.5 meters away from Pam. So the question asks now, Pam views the image of a vase which is 0.5 meters away from her. How far from Pam is the image of the vase? Right, so one of the things that you should know when you're talking about reflection is that the image is equal distance behind the mirror as the object is in front of the mirror when you're looking at a plane mirror. In this diagram, it's a plane mirror, right? So the image formed is an equal distance behind the mirror as the object is in front of the mirror. Good. So if the image is 7.5 meters in front of the mirror, it means that the image is also 7.5 meters behind the mirror. Good. Now Pam wants to know how far is the image away from her. So it'll be 7.5 plus the 7.5 plus the 0.5. Good. Which gives us a more appropriate answer of D. Right? D is the most appropriate answer there, or the accurate answer, I should say. Right, D of 15.5 meters. Good. So 7.5 plus 7.5 plus D 0.5. Next question says here, the diagram below shows an object O which forms an image I when placed in front of a converging lens. So OI is the principal axis of the lens, and the path of one ray from the object is shown going to the image. The magnification produced by the lens above can be found from the ratio of what? Good. Sorry, this question is should have been edited properly. It should have been OC over OI, IC over OC, IP over OP, and IP. Yeah, IP over IC. All right. So in this case, our answer should be B. All right, IC over OP, because magnification is the image distance over the object distance, right? Alright, so the answer there is B. Alright, IC over OC. Number 27. For which of the following objects, this object distance with a convex lens of focal length 18 centimeters produce a real image? Alright. Now, in this case, what we're seeing here, you have to understand this question is asking. The focal length of the lens is 18 centimeters, right? And we want to know where it is going to produce a real image. Now, for I, which is 15 centimeters, it lets you know that the 15 centimeter is between the principal focus and the optical center. And when an image object is placed at that position, it's going to produce a virtual image, right? Basically, no image is formed; it goes straight to infinity. At 36, that means the object is beyond the second principal focus, or at the second principal focus, sorry, right? And that actually creates a real image, right? And that real image is the same size as the object. Good. And part a tree 54 centimeters, right? That is also beyond the second principal focus, and an object that is placed beyond the second principal focus actually creates a real image, right? That is actually smaller. Good. So for number 27, the most appropriate answer there will be B. Good. B is the most appropriate answer. So anytime you do a multiple choice question, even though you have a time frame, you need to look at the facts of the question. Once you look at the facts of the question, you can be able to answer them appropriately. Number 28. Now it says that an object is placed at the bottom of a tank of water and viewed vertically. Good. And from above, which of the following will be true if the image true of the image of the object? Good. 1, we have it is virtual. 2, it is diminished. And 3, it is nearer to the eye than the object. Alright, and the most appropriate answer there will be that the image form is actually virtual and the image is actually nearer to the eye than the actual object. Alright, so C is the most appropriate answer in this case. Alright. Number 29 says refers to the following diagram at right angle glass prism ABC. Alright. Now, so what this diagram is showing here is that a ray of light is originating from X. Good. And as this ray of light originates from X, it is going to move around inside the glass prism, right, due to the process of refraction. Good. It's going to bend. Now it is a 45-degree angle prism, and what it says is that the critical angle of the glass prism is 42 degrees. Good. Now they want to know where would the ray of light emerge, in what direction. Will it be Q, R, S, or P? Now what you should know, that when you're moving from an optically dense material into an optically less dense material, is that you have to consider the critical angle in this case. So at this point, we know the ray enters into the glass block. So we want to know what happens as it tries to leave the glass block here. Now, the ray is coming straight down at this point. So the angle of it enters here is at 90 degrees. Now the ray is touching this side of the glass prism AC. Now because it touches the side of the glass prism AC, we want to determine now the critical angle, sorry, the angle of incidence here. So we want to now determine the angle of incidence at that point. So what we have to do now is determine the normal. Right? So let's say that is our normal line here. So our angle of incidence is actually the angle between the normal and the incident ray, this angle here. And when in process of maths, you're going to realize that this angle is 45 degrees, right? This angle here is 45. Right, so this angle is 45, and because it is 45, it means that 45 degrees is actually more than the 42, right? It's more than the 42. And because that angle is more than 42, it means that it is going to totally internally reflect. So at this point, it is going to go in this direction. This ray is going to totally internally reflect. So this angle 45 is going to be equal to this angle 45. Good? So our answer there is going to be A. A is going to be the most appropriate answer in this case. Good? Next question, number 30. Says a ray of light in air strikes a glass block at an angle of incidence 0 degrees. Good? So that's the angle of incidence, 0 degrees. The light will be either A, will it be undeviated, totally internally reflected, refracted at 90, or refracted at an unknown angle. Now the answer in this case is actually it's undeviated, right? Because it means that the ray is actually going um, parallel to the normal, right? So there is no angle of incidence, right? It is going parallel to the normal. 31, refractive index of a transparent medium with a critical angle C for light traveling. So the answer for number 31 is going to be sine C. Okay. Number 32. The total internal reflection of a glass occurs when, and that answer there, number 32, is when the critical angle is exceeded. That's when total internal reflection occurs. Number 33, if a convergent lens is used as a magnifying glass, the image formed is, right, so in this case now, I want you to pay very close attention to this. We're saying that a convergent lens is used as a magnifying glass. Now, with a magnifying glass, we're going to find out the image formed is actually a virtual image. All right, when you're using a magnifying lens, it is making a virtual image, and the image is actually magnified, right? And because that image is magnified, it means that also we see it upright as it normally is behind the lens. So it means that the most appropriate answer there is D, that the image is virtual, erect, and magnified. So that's the answer for that question. And last question for today, let's look at number 34. It says the following diagram, which shows a light ray which is incident at the air glass interface at an angle of incidence 50 degrees, right? If the critical angle of for glass is 45 degrees, the light will be what? Right, so then again, we want to see again that our angle of incidence in this question is 50 degrees, right? And just as we said before, if the angle of incidence is greater than the critical angle, it means that total internal reflection is going to occur. So in this case, this question, in moving from a more dense medium to a less dense, moving from glass to air, right? We have to consider the critical angle. So we say that total internal reflection occurs. So our answer for this question is going to be A. All right. All right. So that concludes our testing for today. I'll try to get some more multiple choice questions so that we can go through. for the remainder of the syllabus, and I'll try my best to explain more again. If you have any questions, please feel free to message and ask your questions, and also like and share this video, and also subscribe to look forward for more videos to come as we prepare ourselves for any exam. All right, so thank you again for tuning in. Later.